In this video, I am going to cover some introductory facts around equations and algebraic expressions and discuss how pronumerals behave in equations and expressions. If we understand these facts, then solving equations will make a lot more sense. So first of all, we need to recall that a pronumeral is a placeholder. It's a placeholder for a numeral when we don't know what the numeral is. And we've used these sorts of things in different circumstances, such as for area of a rectangle, we say the equation for finding the area is length times width. And we have three pronumerals here, A, L, and W, and they're placeholders. So if we know what the value of the length of the rectangle is, and we know what its width is, then we can use those two to work out the area. Now, in this specific relationship, we have an algebraic expression. The expression has two terms. Terms are separated by pluses, minuses, and equal signs, or inequality signs for that matter. I've got one term here and one term here. L and W can take any positive value because length can't be negative. And then the value of A depends on the value of L and W. I'm going to write another algebraic expression. Say we have 3x plus 2. Now, x is a placeholder, and x can have any value I want to put in there. It can be negative 11, it can be pi, it can be square root of 2, it can be 3, it can be 5, whatever I want, I can substitute in that. And there is no problems there. We can then just evaluate if it's simple enough by ourselves or using a calculator. But as soon as I say 3x plus 2 must equal to, say, 17, then I can't just put any value in there. For example, if I put negative 11 in there, I end up with negative 33 plus 2, which is negative 31. And negative 31 does not equal to 17. So it doesn't, negative 11 doesn't work here. It doesn't make my equation true. But if I had just 3x plus 2, there is no problems with substituting negative 11 in there. That would give me negative 33 plus 2, and we know that's equal to negative 31. So depending on the circumstance, pronumerals behave in a couple of different ways. Either we have a situation where we can put whatever value we want into our pronumeral. So the pronumeral is referred to as a variable. Its value can vary. Or we can only put in a very specific value into our pronumeral to make this statement, the mathematical statement, the expression, true. And in this case, then our pronumeral is fixed or it's constant. It's not a variable, it has a very unique value. So just a reminder, an algebraic expression is one that's got multiple terms separated by either pluses, minuses, or equal, or for that matter, inequality signs. If the expression contains one of these signs, then it's also classified as an equation. If it doesn't have an equal, greater than, or smaller than sign, then it's just a plain old expression. So we need to understand that before we can start working on our equations. And the most important thing is we are looking for a unique value that makes this whole statement true. Especially for the equations we're going to look at in stage 4, there's only one unique value.